Shout out to my man Antonio for reminding me to record. Cassie's going to get all huffy right now without me even looking at her because she also reminded me to record. So when she went like this, I already knew she was going to do that. And she did, didn't she, Antonio? Yeah! Throwing her right under the bus. Okay. Please, 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 please remember from the 9th grade that this is the base. This is the exponent. Okay? And a power is the base repeatedly multiplied. Now, somebody in this room, more than once, is going to have their brain shut off, and I'm going to say, what is that? And somebody is going to say 21. It's okay. Someone's going to do it. I won't make fun of you. It happens. You just see 7 and 3, and you've been listening to me all year talk about knowing your times tables. And 7 times 3, 21, 21! Of course it isn't, because what is it really? 7 times 7 times 7. 7 repeated thrice, which is 343. Okay? Now, this is the last time, one of the very last times in this unit that you are going to use your calculator. Okay? And I'm going to remind you that on your calculator, you are looking for one of 4 buttons to do these. X with a little y, y with a little x, a little mountain, which is called a caret, or the newest calculator for people that really don't understand math, X with a little blank up there. Because apparently putting a y there, people using calculators now are so bad at math that they don't understand that y means variable. So they have to put a blank. So to do this on your calculator, it is base, whatever the base is, then you hit your exponent button, then you hit your exponent, then you hit equals. Very rarely will we, that's hard to say, very rarely will we be using our calculators to evaluate exponents. Almost never. Okay? But I need all of you to be able to do it. So to punch this in, this, 7's your base, 3's your exponent. So you do base, exponent button, exponent, and equals. Everyone can make their calculator say 343, yes? Everyone is good? Okay, so reminder from last year. The base, that is the factor which repeats. That is its actual definition, okay? Here is what I need you to remember that all kids forget. It is only the expression don't put that big L yet, directly left of the exponent. Please underline, highlight, do something with directly left. What do I mean by that? This is what I mean by that. 7 squared. What's the base? What's the base? 7. Excellent. Negative 7 squared. What's the base? No. 7. Negative 7 squared. What's the base? Negative 7. Because the brackets hold the negative in there right next to the exponent. Got it? And one last thing that I have to add because you're in grade 10 now. 3x squared. What's the base? No. X. Got it? because x is what's right next to the exponent. Good? All right. The exponent, okay? It's the number of factors. Okay? We call it, and this is a new word, the superscript. Because it's above the line. Now, you guys are smart kids. Have we seen in this unit a little number written above the line that tells us the number of factors? When? Is that little 3 written above the line? And it tells us we're looking for a group of 3 factors, yes? So you've already seen this. A power. This is a mistake people make when they discuss math. Everyone says that the power here is 3. No. The power is the base and the exponent. It's to the 3rd power, but the whole thing is the base and the exponent. And we read that as 7 to the 3rd. Or 7 cubed, but never mind. Is everybody okay with that? What are the only 2 exponents that get special names? 3 equals cubed. And what's the only other one? 2 equals squared. Everybody cool? All right, now, this whole chart here is the 9th grade. It is everything you learned in grade 9 math about exponents, which means all of you should be able to fill in every blank. Yes? Go. You can talk to your neighbor if you don't remember. Okay? I'm going to turn off the screen so you can't look up here. You have to actually either remember it or ask someone. Then I'm going to keep recording while I fill it in, though. You won't see it, but the YouTube video will have it. Okay? Yep. Yep. Is everybody done? Okay, I'm going to bring the screen back up and talk about a couple of things in a moment. The first thing I want to talk about is this thing highlighted in blue. Why do I not have a number there? Because it's x. You don't know what x is. You cannot go any further. You cannot evaluate that unless somebody tells you x equals whatever. Okay? Yeah. Okay, everybody cool? All right, the next one I want to talk about is this one that I'm highlighting in yellow. I wrote it in two ways, because it could have been negative 3 squared, which is negative 3 times negative 3 to get positive 9. But it could also have been 9 to the 1. Okay? I also want to talk about this one that I'm highlighting in green. Since it was negative 32, but my base was positive, I had to write it this way. I couldn't have brackets. Why? Because if you do negative 2 to the 5th, you will get negative 32. But why did I have to write it this way without brackets? Because I specified that the base was positive. Does everybody understand that? Again, this is grade 9 works. Everybody okay? And then finally, this one. The negative 4 has to repeat. Negative times a negative is a positive, times a negative is a negative, times a negative is a positive, times a negative is a negative, times a negative is a positive. So negative 4 to the 6th is positive 4,096, but there's a negative out in front, so that wins at the end. Is everybody good with grade 9 exponents? Everyone? Okay, now listen to me. In grade 9, technically last year, you only had to do exponents with numbers. Technically. If you were in my class, we covered this as well. Okay? But you didn't have to. Please notice that the rules are the same. X was the base, so there were 3 x's. Okay? If you didn't talk about variables as a base in the 9th grade, is there anybody that was not aware that that happened? Okay, good. Everyone is good? All right, we continue onward and upward by reminding you of the 3 easy laws that you learned in the 9th grade. You already know how to do the first 3. Multiplying powers of the same base. So we're going to do this in 3 steps for each one, even though you already know it. 2 squared times 2 cubed. What's that really? 2 times 2 times 2 times 2 times 2 to get a final answer of 2 to the 5th. What's the law in the shortcut? You just add the exponents. When base is the same, you add the exponents. You already knew that from the 9th grade, yes? But you may not have written it this way. X to the A times X to the B equals X to the a plus b. Now, guys, please notice, x means what? Any number. Can it be a fraction? Can it be a decimal? Can it be negative? Can it be positive? Can it be negative infinity? Can it be positive infinity? So the rules don't change no matter what it looks like. Got it? That's not news to anyone, is it? Okay, just to remind you very quickly, do not write down what I'm about to do. Just think about it. Can I do anything here? Look closely at what I just wrote. Look closer at what I just wrote, Caitlin. Can I do anything there? No. Don't be fooled. Got it? No law for adding. You guys are smart kids. Again, we're going to write it out normally. Dividing. 2 cubed divided, actually no, I lie. I want to make this bigger. 2 to the 4th divided by 2 squared. That's the way most of you saw it in the 9th grade. In grade 10, you're going to see that written the other way we do division. That way. And what does it really mean? 2 times 2 times 2 times 2 over 2 times 2. What do I get to do with these two 2's? Cancel them. Everyone just cancel them. What does that mean? No. With these 2's. You're jumping to the actual answer, Caitlin, which is where I want. You're going to answer the next thing I'm going to ask. Why do I get to do this? Everyone says just cancel. What does it mean? They're the same factor. 2 divided by 2 is 1, correct? Does 1 change any value after it? No. Cancel, cancel, and what am I left with? 2 times 2. Math guys are lazy. They don't write 2 times 2. What do they write? 2 squared. Caitlin, what's the rule? Right. Divide, we subtract. Which you all already know. How do I write that out as a rule? X to the a divided by x to the b gets me x to the a minus b. Everybody Gouda. Great. Nothing new yet, right? And finally, because you guys should have, you won't have a blank below me, an exponent to an exponent. 2, oh crap, go back to black. 2 to the 3rd squared. What does that really mean? What's the base here? 2 cubed. So it is 2 cubed times 2 cubed, which is 2 times 2 times 2 times 2 times 2 times 2, which is 2 to the 6th. What's the shortcut? Multiply. When we have power to a power, power to a power, we multiply exponents. So what does it look like? X to the a all to the b is x to the a times b. That is where grade 9 was supposed to end for everyone. Most of you went further. If you were in my class, you went further. But everybody should have seen those 3 things last year, did you? Yes? So all of you right now, may I see your purple? Oh, I have a purple book right here. You guys right now have 4, 5, and 6, yes? Okay. So I'm going to go ahead and my numbers have changed. This is your number 4, right? fraction base with an exponent. You know this as well. 3 over 4 squared. What's the base? 3/4. Squared means what? So it's really 3 squared over 4 squared, yes? Everybody cool? Right? What does that mean? The exponent goes everywhere. Yeah? Everyone is good? So how do we write it? X over y to the a equals x to the a, y to the a. Everybody cool? Everyone is still good? We're still not at anything incredibly new. Now, this is your number 5, yes? Exponent of 0? Okay. You should have a big space here, yes? I want to show you this in 2 ways because there's a lot of information here. All of you are going to tell me you already know this, but there's a lot of information here. What is 3 cubed? Really? What is 3 cubed really? 3 times 3 times 3 and 27, yes? What is 3 squared really? 3 times 3, 9. What math did you do here? How did I get from 27 to 9? Divided by 3. I divided by the base, didn't I? So you guys are smart kids. What's 3 to the 1? 3. So divide by 3. It equals 3, yes? What is the next logical exponent? 3 to the 0. So logically, I'm going to divide by 3, aren't I? To get 1. Can I write 3 to the 0 as any kind of repeated multiplication? No. But it equals 1. Now, you guys are smart kids. If that happens once in math, how often does it happen? Always. That's one thing I wanted to show you. The other thing I want to show you is this. What is 3 cubed divided by 3 cubed? Isn't that 3 to the 3 minus 3? And isn't 3 minus 3 3 to the 0? And isn't the same thing on top and bottom of a fraction always 1? Is everyone okay with that? That's the other reason. And now, the last thing I want to show you about this is another reminder from the 9th grade. What is 2 to the 0? What is it? 1. Why? You just proved it over here. Because everything to the 0 is 1, yes? So what is negative 2 to the 0? 1. What is negative 2 to the 0? Negative 1. Why? Because the exponent doesn't count with the negative because there's no brackets. Is everybody good with 0 exponents? Yes? Okay. Now we're going to get to something that for some of you is totally new. Totally new. All right? Some of you will have seen this in the 9th grade. Okay, but for some of you, what I'm about to talk about is totally new. Negative exponents. I'm going to write one out. 2 to the negative 3. What's the base? 2. What's the exponent? Negative 3. We know what an exponent means, yes? The exponent is how many times we are going to repeat the base, yes? So, what does that mean? What's my base? 2. I'm going to repeat it how many times? Negative 3 times, yes? Okay, there's 2. Everyone agree? Repeat it 3 times. 2 times 2 is what? 4. 2 times 2, yes? Times 2 again? 8. Everyone agree? Easy peasy. Okay, 2, repeat it negatively. Can you do it? Can I repeat this negatively? Does this make any kind of sense? That's okay. Does 2 to the negative 3 make any kind of sense to write it as repeated multiplication? Yes or no? No, it doesn't. This makes no sense. This is nonsense as repeated multiplication, isn't it? Does everyone agree? You can't show it, can you? But, some of you already know this, I know, but bear with me. This chart we made right here, do it again. 2 squared is what? 4. Agreed? 2 to the 1 is 2. Agreed? Because I divided by 2, yes? 2 to the 0 is what? 1. Because I divided by 2, didn't I? You're smart kids. What is the logical next exponent? 2 to the negative 1. What do I do here? Divide by 2. So I had 1, and I get 1 over 2. 1 divided by 2. Everyone see? What's the next logical exponent? 2 to the negative 2. Divide that by 2. That's 1/4, isn't it? If I take a half and I cut it in half, I get quarters, yes? What is 2 to the negative 3 then? 1/8. Does everybody see the pattern? 2 to the positive 3 was 8. What's 2 to the negative 3? 1 over 8. 2 to the positive 2 was 4. What's 2 to the negative 2? 1 over 4. Is everybody with me? So now, I want to show you one more thing with that. Here's another reason it works. What's 2 squared divided by 2 to the 5th? What exponent law should we do there when we're dividing? Subtract, right? So that should be 2 times 2 over 2 times 2 times 2 times 2 times 2, correct? Everyone agree? What do I get to do with these 2's? Cancel, cancel. What's left? 2 to the 3 on the bottom of a fraction, yes? What must I write on the top of a fraction? Can I put 0? I have to put 1, don't I? Because if I put 0, it's 0, yes? But we know it can't be 0. Everybody good? Everybody okay? Now there's a problem with this. This bothers me. This becomes 2 to the negative 3, correct? And we say to ourselves, self, I can't have a negative exponent, can I? It must be this fraction. Everyone agree? Everyone sees why, correct? So, what is wrong with this expression? Why do I have to stop there and think? The negative 3 is what's messing us up, yes? Because we know there can't be a negative exponent, yeah? So what happens then and I just want to put this off to the side. Use your thinking caps. What is that? What's not allowed there? The negative exponent, correct? When the negative exponent was here, it was technically over what number? 1. So what did we do? We reciprocated, didn't we? Does everyone see that? And you've all been explained why, yeah? So what's not allowed here? That negative exponent. So what do I do when I see a negative exponent? I reciprocate. So what does this reciprocate into? 2 to the what? Two to the negative 3 when it was in the numerator became 2 to the positive 3 when it went to the denominator. Here's why. So what's going to happen here? What's going to happen to that negative 3 when it moves up to the denominator? Up to the numerator? Positive over what? Do we ever write that? So that is 2 to the positive 3. Does everybody see that? If your exponent is in the numerator and it's negative, it has to go to the denominator, and you have seen why, right? If it's in the denominator and it's negative, it has to go to the numerator because it's the opposite. Is everybody good? Okay, I'm going to stop there on purpose because negative exponents for most of you is something totally new. How many people had seen that before, other than Antonio, because he went and Jaden and Maggie, because they went to school in another country where they actually teach better math? Had anybody else seen negative? Well, you, of course, have seen negative exponents because you were in my class. Had anybody else seen those? All right, so we're going to stop there. Do page 82 as practice for Wednesday. Tomorrow, we are going to continue with exponents, but you have no work on exponents tonight. Good? Good.